All right, let's just dive right into this. Welcome to today's Explainer. We are embarking on a truly fascinating journey through architectural history today. We're going to explore how humanity's approach to defense literally shifted from touching the sky to hugging the earth. It's this brilliant story of engineering, adaptation, and survival. And honestly, it is a perfect example of how one single technological disruption can completely reshape the entire world. You know, for centuries, medieval castles were built straight up. The whole logic of a fortress, its very foundation, was based on vertical height. Basically, the taller the walls, the safer the people inside. But when the fundamental engineering problem changed, architects were suddenly forced to abandon the clouds. They had to start spreading their defenses outward across the landscape, completely reimagining what it even meant to build a secure structure. So, to really understand the shift, let's start by looking closely at the vertical era. Picture your classic medieval castle. You've got these high stone walls, soaring vertical towers that just absolutely dominate the skyline. For generations, the primary engineering problem they were solving was gravity. Specifically, they needed to prevent an onslaught of attackers from physically scaling the walls. And these towering, imposing structures, they worked flawlessly for that. They served brilliantly as high-status retreats for elites and as vital, impenetrable safe havens for local populations hiding from ground assaults. In this era, height literally equaled safety. But then, everything changes. We hit this massive, earth-shaking turning point in the 15th century, because suddenly, engineers had to answer a terrifying new question. How do you survive cannon fire? The arrival of black powder and heavy artillery completely shattered the old rules of engagement. Imagine the deafening noise of those early bombardments. Almost overnight, those towering stone walls weren't a symbol of unyielding strength anymore. They became massive, highly visible, and incredibly vulnerable targets. Think about the physics here. When a heavy cannonball slams into a flat, rigid, vertical stone wall at tremendous speed, that wall doesn't just crack. It completely shatters. The immense kinetic energy turns the stone into deadly, flying shards, effectively weaponizing the wall against its own defenders. So the architectural solution required a total inversion of the old physics. New defenses had to be low, thick, and horizontal. Instead of trying to rigidly deflect an impact and breaking in the process, these new structures were expertly designed to absorb it. And that brings us to a pretty radical architectural solution: sinking the defenses. To survive this devastating new artillery, architects realized they literally had to sink their designs right into the landscape. Walls got significantly lower and dramatically thicker. Engineers began reinforcing the exterior masonry with massive, dense embankments of earth, packed tightly right behind the walls. By keeping a lower profile, fortresses presented a much smaller target to enemy gunners. And, more importantly, the sheer, unimaginable mass of all that hand-moved earth effortlessly soaked up the kinetic energy of incoming projectiles. Now, this shift wasn't just about shape. It was about the actual materials being used. As we've seen, high traditional stone shatters, while thick earth absorbs. But in places like Spanish Florida, engineers turned to a uniquely local and honestly surprising solution: porous coquina. This is a sedimentary rock made entirely of compressed shell fragments. When a cannonball slammed into a coquina wall, it didn't shatter. The porous material just compressed, essentially swallowing the cannonball whole without ruining the wall's structural integrity. It's a brilliant, entirely unexpected example of material adaptation under fire. So we've got the specialized materials, and we have the low profile. Now, enter the bastion. This is really the true innovation of the era. A bastion is basically a projecting diamond or angle-shaped formation added directly to the outside of fortress walls. Originating in 15th century Italy, this wasn't just some aesthetic choice. It was a highly calculated mathematical upgrade to the simple medieval round tower, designed specifically to eliminate deadly blind spots. The strict geometry behind this is absolutely fascinating. First, by projecting outward from the main wall, the bastion completely eliminated dead zones. Those critical blind spots right at the base of a vertical wall where an enemy could just hide safely from the defenders above. Second, and most importantly, this precise geometry created overlapping, interlocking fields of fire. Defenders could now catch incoming forces in a lethal crossfire from multiple directions all at once. The fortress was no longer just a passive shield, it was an active, mathematically perfected weapon. When you start connecting all these geometric points together, well, you get the iconic star fort system. Now, while pure geometry created that beautiful, symmetrical star shape in theory, the reality on the ground was usually a lot messier. Not every bastion fort was a perfect star. These were sprawling, highly complex designs. Brilliant engineers constantly had to adjust and deform their blueprints to fit the harsh realities of local terrain, natural water features, steep hillsides, and, of course, the ever-present limitations of the royal treasury. And speaking of the treasury, it's absolutely crucial to understand that these forts were way more than just military outposts. They were the mega projects of their day. Think of them like building a modern megadam or launching a space program. They were massive triumphs of administration. You needed highly trained, visionary engineers like Ignacio Daza. You needed a vast workforce of skilled artisans and a massive, continuous deployment of manual laborers. On top of all that, these sprawling structures required constant, never-ending maintenance of masonry, brick, and stone. The financial investment required by a state or empire to build and maintain just one of these systems was simply colossal. But the architectural revolution was so incredibly effective that it spread across the globe like wildfire. From its 15th century origins in Italy, it quickly scaled up. By 1593, we see the founding of Palmanova, a breathtakingly perfect radial star-shaped fortress city built as a massive piece of a Venetian defensive network. And this system was so globally dominant that centuries later, and an entire ocean away, it was still the gold standard. Jump to 1799, and the construction of Fort McHenry begins in Baltimore, a highly refined, five-pointed American star fort designed for a brand new era of coastal defense. As we wrap up, I want to leave you with this thought. The star fort was not created by geometry alone. It emerged when architecture, materials, political power, and changing technology became one defensive system. Which leaves us with a truly fascinating question to ponder today. If a single change in weaponry forced humanity to entirely flatten and radically redesign its cities centuries ago, what unseen technological shifts are fundamentally reshaping the architecture of our world right now? Thanks so much for joining this explainer, and we will see you next time.